It gives us this graph and it says the figure to the right shows combinations of capital and labor that can produce 20 units and combinations that cost $50. Well, first let's take a look at what that's saying. We see this line, this curved line, we call the isoquant line. It's similar to our indifference curve from our utility maximization section. Well, that line is telling us different combinations of labor and capital that can produce 20 units. This straight line, this is called our isocost line. That is similar to our budget constraint. That's telling us different combinations that cost $50. So now that we have that settled, the question says, at point A, which of the following is true? So at point A, what's going on? And it gives us these different answer choices. So before we look at those different answer choices, let's look at how I would solve this. Well, from the graph, we notice that we're producing at this amount of capital and this amount of labor, Ka and La. We notice that with the same $50, we could be producing more units. We could be reaching this isoquant line, which is farther out. So where the first one was Q equals 20, this one is something more. We're not sure how much more, but we know that we could be reaching a farther isoquant line. So we're not maximizing profit or minimizing costs in this case. So we would like to be at L star and K star, which means we would like to be using less labor and more capital. So at point A, we are using too much labor and too little capital. And there are a few ways to represent this as an inequality. So let's take a look at a few different ways we could possibly represent this as an inequality. Well, this is saying that MPL over W is less than the MPK over R, which is saying that the bang per buck for labor is less than the bang per buck for capital, which is true at point A. So we can rearrange this by cross-multiplying the W and the MPK. So they're going to switch places. And we'll have this function. Well, this is saying that the rate at which we would like to substitute labor for capital is less than the rate at which the market will let us. So the left side is known as the marginal rate of technical substitution. So you may also see this written as this. We've just defined that left side as the MRTS L to K. So all three of these things are telling us the same thing, and that is we would like less labor and more capital. The next question says, various combinations of capital and labor capable of producing any number of units are approximated by the function Q equals K squared times L, all divided by 4. It says the price of labor, W, is 9, and the cost of capital, R, is 3, and then it asks what capital to labor ratio would minimize cost. So it's asking us for K divided by L. Well, we know to minimize cost, we're going to use our equal bang for buck formula, which says the marginal product of labor divided by the wage rate must be set equal to the marginal product of capital divided by the cost of capital. The marginal product of labor we know is the derivative of the production function with respect to L, and the marginal product of capital is the derivative with respect to K. So finding the starting with the production function, which is Q equals K squared times L all over 4, we can rearrange that to make our derivative easier. So instead of dividing it all by 4, we can multiply everything by 1/4. So we haven't changed anything yet. This helps us taking the derivative. Now we can take the derivative with respect to L and get our marginal product of labor, which will be 1/4 K squared. We take the derivative with respect to K, which will be our marginal product of capital, and that gives us 1/2 K times L. So now that we have both of our marginal products, we already know the cost of each thing, we know W and R, we can plug them into our equal bang for buck formula. The easiest way to do this is to cross multiply, so that 3 is going to be multiplied by the 1/4 K squared, and we're going to get 3/4 K squared. That 9 is going to be multiplied by the 1/2 KL, and we're going to get 9/2 KL. Now what we can do is multiply everything through by 4. So on the left side, 3/4 K squared times 4 just gives us 3K squared. The 4 in the numerator cancels with the 4 in the denominator. On the right side, 4 times 9 is 36, divided by 2 is 18. So that simplifies to 18KL. From here, we can divide everything through by 3K. This does something nice. It cancels a bunch of stuff for us, and we're left with K equals 6L. So now that we have what K equals in terms of L, we can answer our question. It was asking for K divided by L. Well, we know that K is just equal to 6L, so 6L divided by L equals 6, which is our answer in this case, which was our optimal capital divided by labor ratio. So K divided by L ratio we find to be 6.